Human eye. Today's topic: refraction through a prism, dispersion of white light, and rainbow formation. In this picture, you can see a prism made of glass showing rainbow colors. Means when white light is entering through a prism, it will be splitting into different colors, the beautiful spectrum. And what is a prism? Two plane surfaces inclined at an angle with respect to each other is known as a prism. There are two interfaces of refraction, and the angle between the two faces is known as angle of the prism. And there are also reflecting surfaces. This picture shows the different areas of a prism: base, apex, and the two sides. See a light ray entering to a prism. The arrow mark is towards the prism and it is marked as incident light ray. Once it enters, it bends towards a normal. Again, you can see it is passing through the prism, and after the deviation or after the refraction, it comes out of the prism. So, if the incident ray is produced using these dotted lines and emergent ray is produced back, you can see the angle marked there. It is known as angle of deviation. So with the blue sketch, you can see the incident ray produced and emergent ray produced back. The angle between these two is known as angle of deviation. Next, what is dispersion? The splitting up of white light into 7 constituent colors through a transparent medium like a glass prism is known as dispersion, and you all have studied the same topic in your 8th standard. What is the cause of dispersion? The spectrum of white light consists of 7 different colors. When these colors or when the sunlight is passing through the prism or a transparent medium, the different colors of the prism travels with different speeds, and the angle of deviation for these different colors are different, and the amount of refraction depends on the speed of colored light in glass. Since the different colors travel with the different speeds, they are refracted by different angles as passing through the glass prism. So, when white light is passing through a transparent medium or a glass prism like this, each color is refracted by a different angle, which finally results into 7 colors known as spectrum. And the 7 different colors are shown here very beautifully. You can see there is an acronym for it: VIBGYOR. Violet, indigo, blue, green, yellow, orange, red. And you can see the color which comes to the lower level is violet and the upper level is red. That means the color which travels fast is red and travels slow is violet. That means the color which deviates most is violet and the color which deviates least is red. Also, the wavelength is different for different colors. Now you can see in this picture how nicely or how beautifully a prism shows the spectrum of this different colors. And here the band of 7 colors formed on a white screen as passing through a prism is called spectrum. The 7 colors, again I am repeating: violet, indigo, blue, green, yellow, orange, red. Now you all know Sir Isaac Newton done an experiment and he allowed the light ray to pass through a prism and it was allowed to disperse into different colors, and he used one another prism in inverted position to get the white light again. This picture shows the same. Here you can see the white light or sunlight passing through the first prism will disperse into different colors, and as it passes through another prism in inverted position will recombine the 7 colors. So here again you can see the color which deviates minimum is red and the color which deviates maximum is violet. Now you can go through rainbow. Rainbow is a natural dispersion process and it occurs in the sky after a rain shower during daytime. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of sun. The water droplets acts like a glass prism or small prisms. They refract and disperse the incident sunlight, then reflect it internally and finally refract it again when it comes out of the rain tube. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. And here you can see how nicely we are watching a rainbow. So this explains the rainbow formation and the processes involved in the rainbow. It is dispersion, total internal reflection. All this together will cause a rainbow, and rainbow is a natural example for dispersion of white light. So thank you.